Hi, and welcome to Adventures with Grandpa on the Sarah Lynn. Today we're in Arnprior, Ontario at Competition Composites Incorporated, where they make boat rudders. So why don't you come along?
I'm sailing, sailing down that river, sailing down that river of dreams. I'm sailing down that river, but it seems that I don't know where I'm going. But when the day is through, I'll come back home to you.
Lewis and Mike were nice enough to take us through the whole design and manufacturing process of sailboat rudders. Step 1 is the design process.
Just take a moment to load up. This software also has design capability, but for surface modeling, like getting nice foil sections and smooth surfaces, Rhino works very well. This is a solid-based design software, whereas the other one's a surface-based design software. So let's see here. I can come in here, see if I can find a boat. I got other Phil's foils. A lot of this stuff is industrial type stuff. Okay, let's see. We got a Cal 39 or a Beneteau. Let's say John Ben 10 here. Let's grab a Beneteau. So in here we can bring in a core design file. I can also show up a rudder file, rudder stock. So in this case, this is the post design for that particular boat. From here we can turn this into a mold. A lot of the time we can do very short runs because we'll do this mold out of MDF, CNC machine it, and it all gets autoclaved in our in-house autoclave. See, this is showing even like wall thicknesses. Phil does all the calculations as far as if they're not specified by the designer. These are autoclaved as one piece. They're continuous fibers all the way around. It's like a bladder mold type thing. So we can do reasonably cheap. We can do even a one-off for somebody that's decided they want to go carbon fiber instead of steel. If I close this out and go to this core.
What's the advantage of the carbon fiber over the steel?
It's, well, lighter for one. You can build in more strength into a thinner blade, typically. You might say longevity, but I think typically the main thing there is it's easy to make a change to it. It's easy to, we can make whatever shape you want without too much, you'd have a little more trouble in a welding shop trying to make a complex shape. And yeah, its strength to weight is vastly superior. I was hoping this would actually have some milling files associated, but this is just a design file. So we'll go back here, see if I can find some milling files. CNC 27 Mark III. This is another boat that has a lot of different variation. That's one down there, I think it's 27 Mark I. So in this software we can come in, design different strategies to deal with the, that's the inside, the shaping. So in this case, because this is a all foam build, there's no real roughing. We can go straight into cutting the shape. So we go ahead and we make a few different operations. In this case, that's a finishing operation right off the bat. Shows us the moves the CNC will make, shows us the cutter, and then there'll be a second operation here, which I'm assuming is to finish up the top details here. That's the milling passes. Basically, we can tailor the milling to what type of material we're cutting. In this case, you can see we're doing 50 thou passes. You get fairly accurate milling with this. that's a fairly fine mill. We'll also have, when this is a solid block, we'll actually start with milling this side of it, and that is basically a pocket to suit the post. In this case, it's a steel post. You have a roughing operation and a finishing operation. Similar to the whole thing. I'm going to turn my stock back on.
I assumed when you put a post hole in that there would be fingers coming this way.
Yeah, so because
but you know, that was just the way I thought it, you know, would be made.
In most, almost 95% of them will have a tang structure. Now, what we've found is when these are, because these posts are usually recovered from a molded rudder, those structures are rarely welded on center or straight, because they have a huge cavity that to fit it in, and they're just pouring in place foam.
Yeah.
It doesn't need to be perfect. So typically with a spade rudder, we don't mill that out unless it's one we built in-house and we know it's straight and where it needs to be. That's where some of the craftsmanship comes in. You have to identify, you know, if the tangs are off center, which side they are, how deep, where to put them, and that's all hand cut. Fortunately, there's just no way around it. You try and put in that design, and it very rarely matches any sort. They don't use jigs. They weld on some plate, throw it inside the blade. So that part's all custom. The only thing you can count on is the diameter of the post and how deep it goes, for the most part. So that part can take a little bit of skill, making sure that the blade goes onto the post oriented correctly and it hasn't been twisted by the structure that we were supplied.
So even with the automation, it's a very hands-on, custom.
It's definitely an artisan product. It's not mass-produced. We do have a few that we mass-produce, but that's you know, a totally different story. I wonder if I could bring anything here. I have an example. Not 1070, because we do them all for this. So here's an example of this is the Matte 1070. So what we have in this case is not a core, but we started with a plug. Oh, I just didn't start. So, oh, I lost it. What just happened? That was Matte 1070. Start a plug. There we go. So what we have here is a representation of the finished blade, including part of the post. Again, this is a carbon post. What we would do there is mill a plug, make fiberglass tooling, and then so you can see that this is one half. I have the other half here, and a cavity designed for placing this in. What we'd basically do is build a fake rudder that's typically made out of MDF or something like that. This is a cavity that would be set into to establish a parting plane. Laminate one half of the tooling, pop it out of this, laminate the other half of the tooling, then you have a closing tooling where all your laminate's laid up with an in-mold coating. Even when we're doing this style of blade, we typically don't use any pour-in-place foams. If we do, it's usually the higher end epoxy, expanding epoxy foams. In this case, we actually do a milled core that gets bonded in with epoxy. So again, you don't have the same problems you have with other molded products, that it won't take on water, doesn't need to be drained after it's been in service for a while.
Right.
So it's like it's the high-end molded. That's what we'll typically do from time to time, not the kind of stuff you find on some of the older boats.
There we go.
I don't know if there's anything else you want from there. Basic design. For this one in particular, we have, this is a good example of a sort of where we run into the non-standardness of these different boats. In this particular example in Ontario 32, the instructions for this one involve laminating the rudder 3/4 of an inch short, we add the core back on and do another lamination that's non-structural over this, so that the customer can come in and has 3/4 of an inch to easily modify the interface between the blade and the boat without compromising the structural integrity of this blade. So again, something we run into quite a bit in this business. This basically shows, you know, how thick the blank is, what to glue up, and in this case, that's 3 plies of a 17-ounce biaxial glass with a 10-ounce over the top. That's what I was talking about. That's non-structural. That's just shape. That's a fairly standard layup for a board of this size. Gives you a little under 1/8 of an inch of laminate. More than strong enough. That would then be put into a traveler. This will have all the instructions that the people need for building. It'll have all the QA sign-offs, what the customer has purchased, and what kind of finishes they want, that kind of thing, and away it goes. This is another boat where it seems every one we get is slightly different. So we have the ability, when the customer sends us their original rudder, we take measurements, we pull their post out, and we can modify our design to suit what they had for the original. Because we find there's a huge variation from boat to boat in a lot of the builds.
Mm-hmm.
So that's a post getting ready to go. I do a small CNC machine. When we get to anything bigger than this, we have to move over to the big guy. We have the capabilities of building some pretty big foils on that machine. For the most part, 90% of what we do in the rudder shop here will be done on this machine.
Right on.
So they pretty much just start as rectangles and then are built to the shape of the rudder.
So you'd actually just laminate this to a size bigger, and then it just cuts it down to size, right?
We have all the dimensions. We know what the final size is going to be. We build a larger stock shape.
So this is like an AutoCAD or design?
We use a Rhinoceros or RhinoCAD. This is just simple line drawings, but the 3D models, that's all done upstairs, and that's where we take the 3D models and turn them into milling files to
Right on.
actually get it all cut.
I don't really have any finishing.
What are these amazing looking things?
These are radar enclosures.
Oh yeah, okay. I read
We do
that.
a few different sizes. These, it's a fairly steady part of the business, but nothing, not our mainstay for sure. Every once in a while they come in. Radar enclosures.
Hi.
That's a part of a geological survey rig.
Bearing compound.
Okay, so the next step from here, so this is so it goes from the design to CNC.
Yeah.
Then it comes out as this product here, which is sort of half wood and half foam, eh?
We refer to that as like a milled core. And we also do spade style rudders.
Yeah.
In which case the cores are made as 2 pieces and bonded around the post before they're laminated.
Right.
We only do a few molded rudders here. For the most part, the run rate on them isn't enough to make it make sense. So the odd production rudder that we picked up, like J111s, we did a production run on. MAT 1010s, we did a production run on. And a couple others, but for the most part, almost every rudder is a one-off custom, which is nice. It allows us to make changes from boat to boat.
Right on.
So anybody who's been in that industry knows that you can have 2 boats that are the same build and never quite exactly the same.
Yeah, I mean, even the sailboats are short run, aren't they? You know?
It's true, Yeah. A lot of the spade rudders where we do carbon posts, we end up leaving the stock over long and sending it to the customer with just the lower bearing installed.
Yes.
Because, especially Beneteau, you go from Beneteau and from boat to boat, the deck height varies by a fair amount. So.
Right on. Mike is showing one that's already been laminated. Go ahead.
So this is an example of the fiberglass cloths used. We have different weights of biaxial. We have 090 orientations, carbons. We use a lot of carbon unidirectional for stiffness. This is where we would kit out, the plies we need before hand lamination. After it's laminated too, we do also wrap these materials, wrap it in a material called peel ply. And what that does is allows us to put a breather cloth across the whole rudder. It's too bad we don't have one in process, but after you wet it out by hand and you're putting it in the vacuum bag, you have a layer of peel ply and a layer of breather cloth. And basically what that'll do is distribute the vacuum evenly across the whole vacuum bag and also absorbs any excess resin. Once that's out of the bag, the peel ply releases from the epoxy surface and leaves a bonding surface because it doesn't really need any prep before adding fairing compound. Okay? So that's a very important part of the step in the process.
I'll give you guys a thank you.
Okay.
Thank you for giving us a tour.
No problem.
Really appreciate your time and effort and the nice high quality products that you're putting out.
Well, hopefully we don't hear from you too soon.
Well, yeah, it's one of those things, right? Anyway, thanks again, gentlemen. Have a great day, and thank you for your time. Thank you for watching. Don't forget to like and subscribe, and come along to our next adventure.
I'm sailing down that river, sailing down that river of dreams. I'm sailing down that river, but it seems that I don't know where I'm going. But when the day is through, I'll come back home.